So welcome to this lecture on duality. In this lecture, we are going to study about dual networks and also dual elements in networks and also an example to understand it. So first of all, you have seen or you must be seeing that duals exist everywhere in nature, like living and non-living, up and down, black and white, male or female. So similar to that in network theory also, we have dual for everything. Like for mesh analysis, we have nodal analysis. For KVL, we have KCL or Kirchhoff voltage law. You have Kirchhoff current law. And similar to that, the voltage and current can also be considered as dual pair. And resistance will have a dual as conductance and vice versa. Inductor can have a dual as capacitor and vice versa. This is L, sorry. And then series analysis has a dual as parallel analysis or parallel circuits, right? So according to the duality rule, if two networks are dual of each other, like if you have one network and if you draw a dual of this network, then whatever the mathematical equation you will write for both of them are going to give you the same result. So the mathematical equation of two dual circuits produce same result, and that is the basis for duality, right? So in these two circuits, you can see that the first one is a series combination of RLC circuit supplied by a voltage source VT, and second circuit is a parallel combination of R dash, L dash and C dash supplied by a current source IT. So these two circuits can be dual of each other if these two mathematical equation becomes exactly same. So we will have to select, like if this is your circuit 1 and if this is your circuit 2. So if you want to convert this circuit 1 into a circuit 2 which looks like it's dual, this can only happen if you have to choose these elements in a certain way. So if you choose these elements IT, V, I dash T, V dash T and so on, with respect to this first circuit elements, so that these equation 1 and equation 2 looks exactly the same, then we can say that the circuit 1 and circuit 2 are dual of each other. So just by seeing initially, if you just ignore that this is V or this is I, can you see that both these equations looks exactly same? So if you have to convert the circuit 1 into its dual of circuit 2, in the circuit 2 you have to replace IT with VT. Whatever the value of VT, you have to replace it with IT. So VT is converted into IT, and if you see here I is converted into V dash, right? Similarly L is converted into C, and here R is converted into 1 upon R dash, and similarly the C will be converted to L here, right? Sorry, L dash. So we are going to write some rules on how to convert any circuit into its dual so that the mathematical expression remains same and we get the same result from both the circuits. So first of all, from this circuit, we will see how to convert this circuit into its dual circuit. So as you can see, this circuit is basically, it has two loops. This is your loop 1 and this is your loop 2. And there are certain elements L1, L2, R and C, and there is a voltage source V. So to convert into its dual circuit, first of all, you have to convert the loops into nodes. So in the previous slide, we saw that the mesh or loop will be converted into node. So first of all, for each loops, we will consider one node, and we will also take one other node, extra node, that we will take it as a reference node. So let me call this as A, this as B, and this as just a reference C node. Okay? Now, what you will do is you will take lines from each of these nodes to the other node through whatever the elements are there between these nodes. For example, between A and C, what are the circuit elements there? So there is a voltage source. So you just connect it like this. And you know that a voltage source will be converted into a current source because the current source is the dual of voltage source. So you will have to make a current source. Now, for the direction, you see that this voltage source will try to bring a current in the clockwise direction of this node, right? This voltage source will try to form a current which is rotating in the clockwise direction around this node A. So if that is the case, you have to make the current directed towards that node, right? If this was positive and this was negative, that means the current was going towards down, and then in that case you would have to have taken your current direction in the downward direction. But since that is not the case, uh, let me draw it again. Since the positive is on the upside, the current will be tried to be formed in the clockwise direction in the first loop. So whatever the current source you will take, it should have the direction towards that node A, right? Around which the mesh is formed. Now, this, let me call this as I. Whatever is the, we will see what will be the value of this current source I. And then you have L1, and you know that any inductor will be converted into capacitor. So let me call this capacitor as C1. And then between A and B node, you have this capacitor. And since this is a capacitor, its dual will be an inductor. So an inductor, you will have to connect between A and B. Now between B and C, you have two elements. First one is resistor, and you know that you have to convert the resistor into a corresponding conductance, right? So we will see what will be the value of this conductance, and then again you will have uh, a capacitor in place of this inductor L2. So let me call this as C2. So your dual circuit can be made. First of all, you draw these nodes A and B, and then your third node C, and then let me call this as L. So between A and B, the dual circuit, your dual circuit will have an inductor L, and then between A and C, you will have one current source I, and also you will have one capacitor whose value is C1, and then between B and C, you have one capacitor whose value is C2, and again you have a conductance whose value is G. Now talking about the values of these elements, since this capacitor is converted into L, this L will actually have the numerical value of C only. Similarly, this G will actually have the numerical value of R only. Similarly, this C1 will have a numerical value of L1, C2 will have a value of L2, and this I will have a value of V, right? So even if you have converted from one form to another, for example, you have converted from a voltage source to current source. Suppose this voltage source was of 10 volts. So you have to take this current source now as 10 amperes. So the form changes, but the numerical value will remain same. Suppose this R was 10 ohm. So now this G value will be 10, but not ohm, it will be mho, right? MHO, mho, or Siemens. So similar to that, all the elements you will convert and keep the values as it is as the first circuit, right? So this circuit is now the dual of the first circuit. So this is your first circuit and this is your second circuit. Now if you try to write the KVL equation for the first circuit and then try to write the KCL equation for the second circuit, what you are going to see is that both these mathematical equation will be exactly same, and the results will also be same. Now let us take an example and try to convert its dual circuit. So we have two loops again. So we will take two reference nodes, two nodes for these loops and one reference node. So let me call them as A, B, and C. Now you see that there is a conductance of 5 mho between A and B. So it will be converted to a resistance value whose value will be 5 ohm. Similarly, between B and C, since there is a 2 ohm resistor, it will be converted to a 2 mho conductance. Now again, there is a 10 farad capacitor between B and C. So it will be converted into an inductor whose value will be 10 Henry. Now coming to the circuits between A and C, if you go through this inductor, this inductor will be converted into a capacitor whose value will be 5 farad, because this value was 5 Henry. And now talking about converting this current source, you can see that this current source is trying to produce a current that is anti-clockwise to the node A. So now when you convert this current source into a voltage source, this voltage source will have a direction whose positive terminal is towards the C direction, because in this case, this voltage source will try to produce a current in the downward direction away from A. So you just remember this rule. If for any loop in the main circuit, if either a voltage source, suppose there is a voltage source across it, and if it is trying to produce a current in the clockwise direction, so whatever the dual circuit you will make, it will have a current source that will be directed towards that particular node A, right? And if the voltage source is having its positive terminal downwards, that means if it is trying to produce current into the anti-clockwise direction, then in that case your current source in the dual circuit will be directed away from A, so it will be towards the reference node. Similar to this, if you have a current source in the primary circuit, if you have a current source in the primary circuit that is trying to produce a current in the clockwise direction across this point A, so if you convert this current source into the voltage source in your dual circuit, its positive direction will be upward, so that the current is produced towards A, right? And if we talk about the opposite, if the current direction is downward, which means this current source is trying to produce a current in the anti-clockwise direction around A, in that case you will have to take the positive direction downwards for the dual voltage source. So that means this voltage source will try to produce a current towards C or away from the point A. So now I think you understand. If the clockwise direction current, then the voltage source will be positive towards that point, and vice versa. And also if the voltage source is trying to produce current in the clockwise direction, then the dual current source will have the current direction towards that point, and vice versa. You just remember this rule, otherwise making a dual circuit is very easy for you. So let us quickly draw the dual circuit finally for this example. So we have A node, B node, and finally C node, and between A and B we have a resistance whose value is 5 ohm. And then between A and C we have a voltage source which is directed downwards, and its value will be how much? 10 volt, because this was 10 ampere current. And there is a capacitor also which is between A and C. Its value will be 5 farad, because the dual inductor had a value of 5 Henry. Similar to that, between B and C we will have an inductor whose value will be 10 Henry, and finally we will have a conductor, a conductance in place of this 2 ohm resistance whose value will be 2 mho, 2 mho. So it is written like this. So this is the dual circuit for this first one. So this is your first circuit, this is your second circuit, and these two circuits are dual. So this is how you can make dual of any circuit. Thank you.